Welcome to aminacademy.com. Let us do Tamil Nadu Higher Secondary second year Maths textbook 2019 onwards, exercise 2.4, question number 6. Find the least value of the positive integer n for which root 3 plus I power n is real and second one is purely imaginary. Now question number 6. Let z equal the given things root 3 plus I power n. Now further we can express like multiply and divide by 2 like this, and split, take out 2 power n common, and root 3 by 2 plus I into 1 by 2 power n. Now here root 3 by 2, the trigonometric function is cos of pi by 6 plus I sine of pi by 6, because sine pi by 6 is half. Now from that, this let it be 1, that is that. From that we can see, before that, further by using De Moivre's theorem, this is 2 power n, the n comes inside, that is cos of n pi by 6 plus I sine n pi by 6, means the power becomes the multiplication of the angles. Now from that we can say z bar is conjugate of this complex number is 2 power n cos of n pi by 6 minus I sine of n pi by 6. Let it be 2. Since z is real, the first condition is for z is real, we can say, then we can say z equal to z bar. Regarding that, we'll equate 1 and 2. 1 equal to 2 power n cos of n pi by 6 plus I sine n pi by 6 equal 2 power n cos of n pi by 6 minus I sine n pi by 6. Here 2 power n cut common both. Then here both side is cos n pi by 6, cos n pi by 6 cut. Then I sine n pi by 6, this side is minus I sine n pi by 6. Collecting one side, it becomes 2I sine n pi by 6 equals 0. Further which gives 2I go as denominator, 0 by 2I is further 0, therefore sine n pi by 6 equal to 0. Now the solution of sine n pi by 6 is, further we can use sine n pi by 6 equals sine 0 is 0, that is sine pi also 0, because sine 180 is 0. From that, releasing sine function both side, we can get it n pi by 6 equal pi. So which gives n pi by 6 equal pi, which gives pi by 6 is 1. Both pi cuts that side. Therefore, n by 6, not pi by 6. n over 6 equal to 1, which gives n equal to 6. Therefore, we got for z is real, for z is real, the least value of n equal to 6. Now the second part we'll do, we have to prove find the least value of positive integer n of root 3 plus I power n for purely imaginary. For second part, purely imaginary, let us do for this. Here for purely imaginary, we know that z must be minus of z bar. For z is a complex number, then for purely imaginary, z must be purely imaginary. That means z must be equal to minus of the conjugate of that complex number. So which gives, same z is, we have already 2 power n cos of n pi by 6 plus I sine of n pi by 6 is equal to minus of z bar. Z bar is same cos n pi by 6 minus, because conjugate, I sine n pi by 6. So both n to here also 2 power n, 2 power n cut both sides, which gives cos n pi by 6 plus I sine n pi by 6 equal minus cos n pi by 6 minus into minus plus I sine n pi by 6. Here both side is I sine n pi by 6 cut, then collecting one side, 2 cos n pi by 6 equals 0. Then further, which gives cos of n pi by 6 equal to 0 by 2 is 0. Then cos of pi by 2, that is cos 90 equal to 0. Instead of 0, we are writing cos pi by 2. Therefore, releasing cos both sides, we give n pi by 6 equal pi by 2. So pi cut both sides. So which gives n by 6 equal 1 by 2. Therefore, which gives n equal to 3. 6 by 2, that is 3. Therefore, the least value of n for z is purely imaginary is n value is 3. So we have done. Please subscribe our YouTube channel.